We shall today study dynamic allocation of data. And as we discussed in the previous class, that suppose we have to write a program which sorts n numbers where the value of n is to be read and the maximum value of n is unknown, then we cannot declare an array of size of some size, say 5,500, because we do not know what is the maximum size. So we have to dynamically allocate within the program some array after having read the value of n. So in the program we will have scanf and then we will have to allocate an array of integers of size n. So we do this by a sequence of definitions and by some standard functions provided in C. Now before we do this, we will see what we have to declare to define an array of such size. So in order to declare an array of size n, after having read n, we will call the statement and we will have to define an array name for it. Now the name of the array is not known to us. So we will define a variable whose content will be the starting address of that array. So we will define b to be a pointer to an integer. Alright, we will define b to be a pointer to an integer. And then we will allocate n elements of that size. And for that we use malloc. And we will have to allocate data of size n elements where each element is the size of an integer. So n multiplied by size of an integer. Size of is a predefined function. This can be any type. It can even be a structure type. Here we have defined it to be integer. So for any type, automatically size of will give me the size of that structure, complex or student record, whatever you want, you can put it here. And n is the number that we wanted after having read n. And we will assign it to b. But before assigning it to b, we have to do what is called typecasting. Now what is typecasting? In C language, suppose I have defined an integer b and I have defined a floating point number x. Now suppose I want to do x is equal to b, and I want, normally when x is made it assigned to b, system does an automatic type change. But if you want to explicitly do this type change, you have to write x is equal to this, converts the expression here to this type, and then this is assigned. On the other hand, if I want to put b is equal to x, I'll have to convert it to an integer and do this conversion of type. Now here I have just got a block of n elements which I have allocated n elements of type integer. So this will just, suppose this will be computed to be say 4, and n into 4, suppose n was 10, n into 4 40 will be, this expression will evaluate to 40 and a block of 40 will be allocated and the address of that location will come. But we want this to be converted to the same type as this. So the type of this is what? Just remove this variable, you will get its type. A very easy way to find out what the type is, just remove the variable name, you will get its type. Int star. Now after having done this, now B, the content of B has got the address. Now this malloc will return the address, int star, this will return the address. So B is now pointing to an array of n elements. You have physically allocated this array of n elements. Now you can read in the n elements for sorting. So we will see 3 examples of dynamic allocation in this class and see how we can allocate, and depending on what we want to allocate and depending on what we write, what is being allocated. So we will see them on the computer and move back onto the terminal as and when required. The first one is a simple one. It is just as we discussed. We defined a pointer variable int star b, and here we have done the allocation. B is equal to int star typecasting malloc 10 into size of integer. Now let us see what happens after malloc. B, what is B? The B will give you the content of B, mind you. When I write B, it means the content of B, because it's a variable. Will give you the address of this. B plus 1, since it's a pointer to an integer, it will increment it by the size of an integer. B plus 2 will increment it by the size of integer, one more. And you can now use it just like you use an array. B2, which is equivalent to what we wrote down in the previous day. When in any array, when I write B2, this is converted to this expression, star of B plus 2, which is the same as here. So you will see when I do B2 equal to 4, I will get star of B plus 2 is equal to 4. So let us see what gets printed at B, B plus 1, B plus 2 and star of B plus 2. This B is 1073, this is the starting location, alright. This is this, and star of B plus 2 is equal to 4. Suppose we made it into a floating point number, then this casting we will have to change. Size of float. The rest will remain identical. There is no change in the rest of them. But this B plus 1 now will jump by a different amount, and which we will see now. Yeah, this is the program. Oh, did we compile it? Yeah. Percentage F we did not give. That's right. No, but here we have given percentage u. That's all right, but let us see. Here we have given b plus 1. This is a pointer to a floating point number. A0 to A4. So here again 4 are allocated. A4 to A8 and B is 4, fine. But only 4 places were allocated. B to B plus 1 and B plus 1 to B plus 2. When you define it to be a character, on the other hand, the sizes were only 1. Just 1, 1 and 1. Now let us see another program. And let us see this declaration. Int star B5. So let's analyze what this means. Suppose I define int star B5. What does this mean? This is equivalent to int or is it equivalent to or are they same? Can you see these two things? What does this mean? And what does this mean? This means that an array of 5 elements, this one means that there is an array of 5 elements and each of them is a pointer to an integer. Int star B5 an array of 5 elements and each of them is a pointer to an integer. So this one, this definition leads to an array of 5 elements. So 5 elements are allocated of pointer type and each of them is a pointer to an integer. So you can now, if you malloc on B0 with 10 elements, you will get 10 elements here. If you malloc on B1, you will get another 10 elements here. If you malloc on B2, malloc on B3, malloc on B4. Alright. So let us see how we will get this program. Here we have done int star b 5. So, we have defined an array of pointers to integers, and in a loop from 0 to 5 we have allocated each bi to 10 integers. So, that way we have defined an array of a 2-dimensional array has been defined. A 2-dimensional array has been defined, 5 by 10, all right, and you can access that 2-dimensional array. For example, b plus 2, what will b plus 2 give you? This is an array of pointers, so it will give you the element which is at the second. It will give you the value of the second point, third pointer b2, and the content of that will give you the start address of that array. Plus 3 will give you the third element address on that array, and content of that will give you b23. All right. So, we will see what is b plus 1, b plus 2, star of b plus 2, star of b plus 2 plus 3, and this is star of the whole of that, which is the same as b23. So, this is the another way, this is one way in which you can define a 2-dimensional array dynamically. Though we have kept this size to be constant for all of them, this size could be varied for each of the i's. For each of these i's, this size, the size here, this 10, could have been different. So, you could have got an array of variable dimensions on each of these columns. If these are the rows, if there are 5 rows, then on each of the columns you would have got a different dimension. B is the start address, b plus 1, b plus 2. This is the content of b plus 2, which is the malloc address. This is the malloc address which you have malloc. These were all initially allocated in that array. This is the malloc address. Content of that b plus 2 plus 3. Plus 3 will move by 12, and then what did we do? We did the star of this, we assigned to 5, which is the same as b23 is equal to 5. So, we have defined a floating point array. Some line 7. It says incompatible type definitions. bi oh. This will define real numbers now. each of them will be a real number. Similarly, if you wanted to define an array of pointers to characters, you could have defined it. An array of pointers to complex numbers, this should have been just complex provided you had defined the type definition of complex, and you would have been able to do that. Now coming back to the other one, this one. What does this mean? To understand what this means, let us see what this means. To understand what this means, let us see what this means. This means A 10, so there is an array A of size 10 integers. So now look at these two. A is the address of the array. So this says the content of B is the address of an array of 10 integers. So what is B? B is a pointer to the first such content. And in order to define a two-dimensional array, if you define 5 such blocks of B, you will get a 5 by 10 array. If you define 20 such blocks of B, because each block is of size 10 elements. The other one was a previous one was a pointer to arrays. The advantage with the previous one, see, look at the previous one, look at this one. Suppose you wanted to define, you are writing an editor and you want to define lines, alright. Now each line will have variable size. Whoever is writing an editor, you will define a character. So you would like to define a pointer to characters, and then whenever somebody has written one line, you will malloc only that size. The next line you will malloc only that size, whatever is written, so many characters. The third line, the fourth line, so on. This way you can malloc variable sizes if it is a pointer array. This is a pointer array. On the other hand, each of them is a block of 5 characters, 5 array of 10 elements. So if you do B plus 1, you will jump 10 integers. If you do B plus 2, you will jump 10 integers. So using this also you can define a two-dimensional array, as we shall see now. Int star x 10. Again malloc 5 into 10 into size of int, that is fine. But the typecasting has to be given carefully. One easy way of giving typecasting, as I told you, just remove the variable name, you will get the type. Remove all the variable names and the values of the constants, you will get the type. Here, just remove this x and this 10. This is one thumb rule which is often usefully applied. Malloc 5 into 10 into size of int. Total 50 blocks have been allocated. Then you decide what is x plus 1, what is x plus 2, what is the content of x plus 1, x plus 2, what is the content of x plus 2 plus 3, and so on. So let us see what this gives. X is this. X plus 1, have you noted that it has jumped by 40 blocks? X plus 2 has jumped by 40 blocks. Content of x plus 2 is the same as this because it points to that two-dimensional array. And plus 3, now it will jump by 12 blocks. And then x23 is equal to 5. So this is another way in which you can define two-dimensional arrays. But these arrays are, each of them are of size fixed, 10, 10, 10, 10, 10, 10. The way they will be stored in the memory will be slightly different depending on, you can see from the way the addresses are stored, you will see how they are stored in the memory. So finally, let us now come to the student record problem that CGPA problem. So now what we want is, we will not define, whenever for one student we will allocate. Okay. So we have given a type def structure for the student. Let's work it out first. Let's work it. For the student record, if you recall, the structure of the student record was something like this. Struct, char, float, stud1. Alright. So what we will now do is, we will not define something like this, we will define only a pointer. And whenever required, we will allocate one student record. So we will do a type def char name 25, type def struct has to be written, no? Char roll number 8, float is GPA 8, float CGPA 8, this is what we had defined. Anyway, I think we also got this definition before. And if you want to have, you don't want, this is just a type declaration, and you can define studrec now you have defined a pointer to that, and you can dynamically allocate it as stud1 is equal to studrec star malloc 1 into, let us say we want only 1. If you want 20, 30, whatever you can do. Suppose you want just 1, then 1 into size of studrec. If you want 20, you can allocate 20 an array. If you want 30, you can allocate 30 elements, whatever you want. But if you want 1, you can allocate only 1. So this is how we allocate it, and but this is now a pointer. So if we want to access the name of this student, then we will have to write down stud1 pointer name. Roll number will be stud1 pointer. The 5th semester CGPA of this student will be because it's 02. So this is just the modification in the student record program that we had written, which will lead us to this structure. So we can have a quick look at that program now. So this is where we have defined this is stud1 is a student type. We malloced this. stud1 is equal to stud type star malloc size of stud type. If nothing is written, it is 1 into. Then give the name of the student. Now in scanf, since it's a string, stud1 dot name will give the name of that string. We don't have to give here. Then roll number pointer, then the number of semesters. Here you'll have to make it, and because this is a floating point number, stud1 pointer CGPA SGPAI. Thus the dots are changed to pointer notations, and the whole thing will run. So if you just, so this is how we can allocate and deallocate even structures, and as I said before, here you can declare even an array of such structures by defining the number of students 10 into 20 into whatever, and then you can access it by stud1 5 pointer roll number. Suppose you allocate 20 here and you want to access the fifth element, then it will be something like this. Stud1 5, that is the fifth element. So we have seen how dynamically we can allocate structures and we can allocate data.